Okay, so they said use Newton method to find the approximate value of this cube root of 3. Give your answer correct of 3 decimal. So of course, our first part will be going to find out what is our function. So you are going to find the value x for cube root of 3. So when you want to build out our function, we have to make it one by one, move it to the left hand side one by one so that our function is polynomial function. So when cube root, when we have a cube root, we move it to the left hand side, it will become x cubed. Then we move our value x cubed minus 3 equals to 0. So our polynomial function x cubed minus 3. This function only suitable for Newton-Raphson method. So, of course, our next step, we're going to find the differential function, power turun depan, power tolak 1. So differentiate number, differentiate constant, we get 0. But for this question, you'll notice that this question doesn't tell us what is our initial value. So when we don't know the initial value, we have to guess ourselves. So our guessing must be based on some logical sentence. Okay, so how we going to do that? So we are going to try and error. Okay, we have to prove our roots is in one interval. What is our interval? We are going to test, like we will test our value of 1. When we substitute inside, you'll notice that this is answer of -2. Negative. So our interval can start from 1 until, so we can test another value. So this interval value is not given, it's up to ourselves. As long as we can prove there is a root in between this function. One make you negative, one make you positive. So means that will be a root in between these two number, 1 and 2. So when I put 2, so 2 cubed minus 3, so 8 minus 3 will be 5. So one positive, one negative. So obviously you can see this has opposite sign. So when this has opposite sign occur, so this algebraic method help us to prove that, okay, since our f1 is negative, f2 is positive, having opposite sign, okay, so therefore we can prove out there exists a root in between. So on our sentence, because our testing value here is based on our value, our testing value here is 1, 2. So therefore our roots is in between 1 and 2. So from here, we can identify our initial value. So you already know there is a root, means there is a x between 1, 2. So our initial value, we can put any numbers. Okay, any numbers as long as it is in between 1 and 2. So our initial value, I will start with 1.5. I take a middle value, value in between them, 1.5. Then only we start with our Newton-Raphson method formula, 1.5 minus fx over f prime x. Okay, then we can start using our calculator. Calculate 1.5. Okay, decimal 1.44, 3 decimal, extra 2, so 44. Four, four, two, two, 5. Okay, then okay, we continue. Oh, so they are same already, so repeated. Okay, so this question gives us a nice question where we can find the answer repeated. So conclusion x, 3 decimal place, 1.442. Okay, so this is how we deal with the question without given initial value. So we have to prove it ourselves, okay, using our interval value, our own interval value, using our initial value. So I said just now, make sure our initial value must be make sense. When you say that is a root between 1, 2, so our initial value, you can take 1.5, 1.6, 1.4, 1.3, as long as this is in between 1, 2, because this is what we prove here. We prove our function one positive, one negative. So that's why there has a root between 1, 2. Okay, so then we can check our answer. Okay, we can check our answer. We can just press cube root of 3 because we are finding this value, right? Cube root of 3, what's the answer? 1.4442, okay? So 3 decimal 442.